Welcome to EDU World Space.
So in this question, we are given the material polystyrene, right? And we are given two loads. This load is being applied in the horizontal direction, right? And it is of 500 pounds. And the other load is applied in the upward direction, and this is of 350 pound per inch, right? Now the dimensions that are given to us is A of 2 inch and B of 2 inch as well, and the thickness is equal to 0.25 inch, right? Now we are given the elasticity and the epsilon for polystyrene, and we are required to find out the new dimensions for this system, right? So first of all, what we are going to do is that we are going to find out the stresses in two directions, right? And for that, what we are going to do is that we are going to um, use the information that we have, that since we are given uniform loads, right, instead of forces, so these stresses in x and y direction, right, so they will be equal to the load, right, divided by the thickness of that area, right? So the load that is being first, and before that we need to figure out our directions, right? So let's say that the upward direction is y-axis and the horizontal direction is x-axis, right? So the load that is being applied in the um, horizontal direction is of 500, right? So 500 divided by the thickness, that is 0.25, and we get our new stress, that is of 2000 ksi, right? And again, this would be same like this. So the load that is being applied in the y direction is of 350, and the thickness is 0.25, so calculated, and that is equal to 1400 ksi. Right now, since we have the stresses, right, so what we are required to do is that we need to apply the Hooke's law, right? So we need to apply the Hooke's law for two dimensions, right? So the Hooke's law for two dimension, for the x direction it's this, right? And why this is zero over here? Because we do not have any z direction, so the z component is zero, right? So we have the um equation, we just need to simplify it. So when we'll simplify it, so we'll get that it is equal to sigma sub x negative epsilon times sigma sub y divided by e, right? You have all these values of all of these variables, just plug them in, and you will get that it is equal to 2.7638 into 10 raised to power negative 3, that is approximately equal to 2.76 into 10 raised to power negative 3, right? And similarly, we have the equation for y dimension, right? Again, the z component is 0, and when we simplify it, we'll get that it is equal to sigma sub y negative epsilon sigma sub x divided by e. Again, just plug in the values and we'll get the strain for the y direction, right? So that is 1.5075 into 10 raised to power negative 3, and that is approximately equal to 1.51 into 10 raised to power negative 3. Right, now what we're going to do is that we need to use the elongation formula, which is this, right? The strain is equal to the change in L divided by L, right? So the change in the x direction, it would be equal to the strain in the x direction times L, right? And that is equal to 2.76 into 10 raised to power negative 3 into 2, and that is equal to 5.52 into 10 raised to power negative 3 inch, right? And sigma sub y, sorry, the change in y is equal to epsilon sub y, the strain in the y direction times L, right? That is equal to 1.55 into 10 raised to power negative 3 into 2, and that is equal to 3.10 into 10 raised to power negative 3 inch, right? Now that we have the change in the x and the y direction, we just need to find out the new dimensions, right? So let's find out the new dimensions. So a dash would be equal to the sum of a plus the change in y direction, right? And b dash would be equal to b plus the change in x direction, right? So a is equal to 2 plus 3 in 0.10 into 10 raised to power negative 3 is equal to 2.00310. This is equal to 2 plus 5.52 into 10 raised to power negative 3, and that is equal to 2.00552, right? So this is your solution.